Hi, everybody. Very little about weather. Mostly I'm going to talk about Watson microservices development, a little bit about what it is. A lot of people are probably curious about why we're talking about Watson at a cloud event. So we've been on Bluemix for, I guess, as long as Bluemix has been around with IBM. We were very early. So what I'm going to do is talk a little bit about what Watson does so you get a sense of what we mean. Talk a little bit about how Watson's used, and then dive into really a discussion about how you build applications using the Watson Developer Cloud, which is a set of Bluemix APIs. So the reason we're building applications like this, a lot of people have seen pictures like this. The reason that people began to work with big data and analytics applications was really about data scale and about, if you like, data noise, data complexity. When you look at the kinds of data that are growing, it's really the unstructured stuff. And we like to say that sort of 80% of the data on the planet is really not accessible to most traditional enterprise applications. As the scale of the data increases, you really can't even look at it per se in the course of an application. So what systems like Watson do is they actually build models of the data, and then they use those models to compute. And the reason they're interesting, if you like, is these models evolve over time as the data evolves over time. So we talk about these systems learning models for the domain in which that they're embedded. I guess it's interesting. There's two pieces of code I'm going to show here. One of them is COBOL, and the other is Ruby. So eclectic. We talk about sort of eras of computing. Back in the day, Herman Hollerith invented punch cards, really about counting. What was interesting there was the beginning of automation, even though the description of the algorithms were codified in the machinery that did the tabulation. In the 50s, the big, I guess, sea change was about packaging data and application together. So really the applications were data themselves, which described instructions. For those of you who don't know COBOL in the room, I may be the only one, that's Hello World. In order to deal with sort of the modern onslaught of data, we sort of date this with the day that Watson played Jeopardy, and I'll talk about that in a minute. Instead of programming these systems, you teach them. You give them data, they actually learn the domains, they learn models, and then they use those models to compute. And you deal with scale, and you deal with real-world modalities, speech, unstructured text, audio, whatever they might be. So the reason we call these cognitive systems, it's a pretty good description of what they do, acquiring knowledge and understanding through thought, experience, and senses. And these systems learn over time. So this system began its life 2011. I thought there was audio, guys.
Boston Rob, the tribe hath spoken.
Let me go
Watson.
back.
What is a survivor?
Let's try that again.
Reality shows a Shakespeare for 200.
Heroes and villains abound. Colby, Coach, and Rupert doth return to the fray, but Boston Rob, the tribe hath spoken. Watson.
What is a survivor?
Look, you've never seen this before.
How do you know that? Good job, Watson.
This is that was a training session. Watson spent years learning how to play Jeopardy. We trained it with things like Wikipedia. And what the system does very well is extracts signal from noise. When people read that clue, they usually go, huh? And basically what Watson did was zero in on things like game show, heroes, villains. And when you do that, the question's pretty straightforward. So really what these kinds of systems do is they listen to signals. They extract meaning from those signals. We talk about feature analysis. They have this notion of why. Why is the system believe that something is true or false? So there's a notion of supporting evidence. And of course, these systems use various kinds of machine learning. Watson itself today began with one capability, question and answering. Now we have about 30. And there's lots of different kinds of signal processing, machine learning algorithms underneath. And the whole point here is to partner with people. We like to say that the system amplifies human cognition. So I'll give you an example of the kinds of things that you do that are very, very difficult for people in general. If you are working for a bank and you're interested in entering into a relationship with another organization, you'd like to know something about pre-existing relationships. They're called counterparty relationships. The way that's done today is through an army of folks who spend their time pawing through SEC filings, doing web searches, and creating, if you like, a report that talks about the relationship between you and this other entity. What we do with Watson is we read all of the filings of pretty much every company on the universe, read them in, organize them, extract things like people's names, companies' names, relationships, and build a knowledge graph that looks something like what's on the right. So the algorithm to determine a counterparty relationship for a researcher is to simply ask the system questions. It's a much different relationship. Now we do this notion of 360-degree views for people as well as for companies. So I mentioned that Watson has 28 microservices on Bluemix. This is one of them called Personality Insights. And it's very easy to use, and that's the characteristic of all these services. You give it, this is actually the landing page, by the way, for the service. And the demo application that comes with it takes as input a bunch of text, analyzes the text, and gives you the personality of the individual who wrote the text. And the way it's trained is by using a dictionary that really correlates word use to personality. And the sample that comes with this is actually President Kennedy's inaugural address. An earlier version was the opening soliloquy from Moby Dick. We computed Ishmael's personality, but I think we ran into some copyright issues, so we went to something a little more public domain. Now, so the demo application that comes with this, the way you typically get started with Watson is you can take it, they're stored in GitHub, download them, modify them, create applications using Bluemix, and away you go. So you can pretty much be up and running with a cognitive application based on any of these APIs in an hour. So what's different here? So number one, I talked about how the Personality Insights application was trained by giving it a dictionary that talks about the relationship between word use and personality. And there's no rules there. It's really just a dictionary, and the system knows how to interpret those dictionaries. So these programs are trained as the training data, in this case the domain, evolves over time. You train it, retrain it, it learns over time, and the results of a query vary a lot, and they vary over time. So lots and lots of training data is required, and I guess what's interesting about these systems in the context of Bluemix, aside from developing a runtime application that does what you wish, there are tools, usually also manifested in Bluemix, to help you train the individual APIs, and I'll talk more about that later. So let me talk about some of the patterns of use. And there's really four major patterns. There's one called discovery, and this one's really about research. If you're a subject matter expert, maybe you're a doctor or an economist or a chemist or a physicist or a lawyer, what you have in common is you're typically asked to take in a lot of data, usually a stack of papers, books, reports, and say something useful. Okay, we get that all the time. So what this system lets you do is look for relationships amongst enormous amounts of unstructured data. If you're a lawyer, you're interested in looking for a case that has relevance to the one you're studying now. If you're a pharma researcher, maybe you're interested in asking if a particular drug can be reused for something that it might not have originally been designed for. So these systems are very, very domain specific. One that we did do that was kind of fun was around food. So we trained the system using Bon Appetit recipes, really. And we built a system which you can play with called Chef Watson. And what it'll do is it'll create new recipes for you. You give it some ingredients, it'll get inspired by the recipes it was trained for. And it discovers the food relationships and gives you something to make for dinner. So that's discovery. Another use case is one we call policy enforcement. This one's pretty easy to understand. It's often the case that policies or rules are codified using text documents. Examples of that might be rules for whether you pay out an insurance claim, rules for which of the different parts of the income tax code apply to a particular individual. If you're a doctor, you're interested in the rules for qualifying your patient for a clinical trial. So what this particular use is about is training the system on these policy documents and testing a particular situation or a case, as we like to call it, against a policy, determining which of these policies apply or if more data is needed. And lots of use cases, some of them are fairly broad. I mentioned clinical trial matching, paying claims is another one. Another use case that we see a lot is decision support. And it's a bit of a funny story. The first place where we deployed Watson after Jeopardy was a domain we didn't expect. We expected pretty standard IBM customers, financial services companies, governments, to come and talk with us. And instead, the people who called us were cancer doctors, oncologists. Very simple reason. They saw Watson answering questions after being trained on a lot of data, and they wanted to know, could you train Watson to help figure out the appropriate treatment for a patient? And the answer is yes. And we built a decision support system, actually a couple of them, with MD Anderson in Texas and Memorial Sloan Kettering here in New York City, all about making treatment recommendations for doctors. And the last pattern I want to talk about before I get into a little bit on the microservices is one we call engagement. Again, the initial exposure to the public of Watson was answering questions. So that's really what this is about. If you are trying to create a self-service call center, for example, or a system that helps a call center agent help, really it's about question and answer. One of the other use cases is something I call a process concierge or a virtual assistant, where you train the system to take somebody through a task and on the way answer questions. Things like commerce, buying things. We built you see Deacon there. We built an application for a university in Australia called Deakin University, which is a student onboarding concierge. So 50,000 students come in every year, and the point of the concierge was to help these students figure out where to go, what to do, what was going to be good about the food in the cafeteria that week, etc. One of the things that proved to be kind of interesting is after we deployed the application in the spring, students in the engineering school wanted to engage, so they're actually modifying their own Watson application by training with new data, adding new capabilities to it. It's kind of interesting. So We've also been trying to teach Watson other languages. This is a video we built with SoftBank in Japan. That's Pepper the robot.
夜の客のお客様、いらっしゃいませ。僕はハンガリーのペッパーです。こう見えて結構物知りなんです。今どんなテレビをお使いですか？
液晶のちょっと古いやつ。
液晶ですね。大きさはどれぐらいですか
43インチくらいかな。
はい、買い替えならワンサイズ
So
大き
he's
いのがお
pretty
すすめ
good,
です
actually. This is not a canned demo. He knows how to upsell. I was
50インチだと画面
kind
が
of
大き
impressed
く
when
な
I
ります
saw
か
it.
ら 4K で美しい映像を見れるテレビをおすすめしますよ。
4K はどこがいいの？
はい、お調べしますね。データベース検索中。現在見られている放送を 4K 放送にアップコンバートしてくれる機能もありますので、4K 以外の放送も高画質で楽しめます。テレビ入力に切り替えますね。しばらくお待ちください。
4K 放送はもう始まってるの？
はい、お調べしますね。データベース検索中。データベース検索中。現在スカパープレミアムにて 4K 総合と 4K 映画が放送開始しています。今後もその他のコンテンツで放送予定が計画されているそうです。
このテレビの他の特徴を教えてくれる？
このテレビには特にお伝えしたい特徴が2つあるよ。1つ目は照明や外光などの映り込みを抑えた低反射液晶パネルを使用。2つ目は色再現範囲を拡大する技術を使って自然で豊かな発色を実現。
そうなんだ。買い時かもね。
買い時です。
So he's kind of cute. So a couple of things to talk about here. So you saw a lot going on there. So a couple of the microservices that Watson does provide are speech to text and text to speech, clearly also in Japanese and a number of other languages. You saw dialogue services, another microservice there. You saw question and answer. The system was trained to know about sharp televisions. And we've added some other things specific for the robot. So there's a robot SDK coming about. So the robot knows how to be expressive. It knows how to look at you. It knows how to be excited. Knows how to be curious. And this one kind of surprised us. Turns out there's a lot of interest in robots nowadays. I did robotics back in 1988 when I started IBM. You all know that I'm old. And I never expected to be involved in robotics ever again. But we're engaging with hotels and concierge robots. You walk into the lobby, say hello, and the robot helps you. So, and this is a case of putting the intelligence of a system like Watson in the back end of an interesting access device. Other examples of access devices that we see are cars, for example, obviously smartphones, telephones using IVR. So let me talk a little bit, switch gears and talk a little bit about what's under the covers, and then I'll get to a microservice discussion. One of the key differences between a search engine and what we're doing is the notion of meaning. So Watson doesn't really deal with syntax. It deals with semantics. It deals with the underlying meaning of the words. So we built a little application. This is actually the demo application for a that's available in there's a downloadable gallery of lots of source code of Watson applications. And this one plays with an API called the Natural Language Classifier. And so on the left, you ask the Natural Language Classifier, how smart are you? And we created a version of Watson that knows about Watson. And it has a little trouble answering the question, but it knows you're asking about intelligence, so it says, do you want to know about this or this or this? And in fact, what's happened is it's done natural language processing to analyze the question. It understands the kinds of questions that it knows about, but it can't with high enough confidence say that you're asking this or this or this, so it gives you options. And when you feed this kind of thing to a normal search engine, you get a syntactic match. In this case, am I dumb intelligence test and things like that. So it gives you a sense of the difference between syntax and semantics. And the personality insights example that I showed you earlier was another example where we're actually going one level deeper than semantics of language, and we're talking about tone and the kind of expression. Sometimes these questions are pretty complicated. Here's an example which I won't read, where the question you ask Watson is in fact a medical record, and the answer is, how do I treat this patient? And you can see that a system that knows how to understand the nuances of medical language or legal language or physical language or chemical language is fairly nuanced. And one of the things we let people do is train different versions of Watson to understand the language that is used in the data that you train it with. So how does all this work? Okay, we talk about a long tail of questions. We began with this thing we call the factoid pipeline, which really answers questions with 1, 2, or 3 word type answers. Who, when, where, not why, not how. And over time, we've been adding new pipelines so Watson understands other kinds of questions. Things about equivalent questions. Oh, I've heard that question before. I know the answer to it. We call them topical answers. Well, once you have more than one different kind of way to answer a question, you have to figure out how to put them together. So there's this technology we call fusion that actually does confidence scoring based on the different pipelines. Again, this is all microservice based, and will help you decide what the right answer is. Some of the other things that we see are frequent questions, memorization. You saw the robot, some of that was dialogue, some of it was open question and answer, predefined questions. The usual example I give is sometimes if you're working for a company, somebody asks a question that you want your lawyer to answer very specifically about liability, say. This is the hard one, explanatory questions, and the way I characterize this is you're really asking Watson, does this paragraph answer a question better than that paragraph? And as a person, that's a hard thing to do. It's kind of like grading essay questions. And the state of the art here is, this is where a lot of the research into question answering is going. Watson knows how to ask disambiguating questions, as you saw. If it's confused, it'll ask for clarification, and then it knows about context. And Pepper the robot knew a lot about the context. It knew that they were talking about televisions. It knew what the subject of the discussion was, so it could carry on a very natural interaction with people. So let me talk a little bit about Bluemix. So one of the things we've been doing with Watson is we have a partner ecosystem where companies take these Watson APIs that I've been talking about, and they add them to applications they might already have or create new ones. This is a company here in New York City called Elemental Path, and that's a Cognitoy. It's a little dinosaur powered by a version of Watson that has a cognitive development model for children. And what the little dinosaur does, aside from tell jokes, is ask the kid questions, it answers questions, and the idea is to discover children that are gifted or children that are perhaps learning disabled early. What was kind of cool, this was probably the first Watson item on Kickstarter. They tripled their funding goal in a day. I mean, he's kind of cute. I'd fund him too. So what's going on here when you look at how people use these APIs is they really create recipes. I've talked about speech recognition. I've talked about classification of natural language and dialogue. And typically, the reason we're using Bluemix is people want to build applications that use a whole bunch of these capabilities. So they write fairly simple applications that mix these things together. And what's kind of interesting about the Watson APIs is that they're relatively easy to use, even though they might do something fairly sophisticated. So you can build interesting applications that do something pretty darn complicated. This chart's a few weeks old. There's currently about 32 APIs out there. This is a list of them, and some of them are obvious: text-to-speech, personality insights I mentioned, machine translation, translates language from one language to another. There's quite a collection of them. What I think I'm going to do is talk about a couple more to give you a sense of this. I mentioned personality insights. This is the landing page. Really what it's about is, if you're going to engage with a person, if you're going to build a system that does, understanding something about that individual's personality is going to give you a better ability to interact with them. Additionally, people always ask about computer dating as a use case. And we had some fairly adventurous interns who showed this to the CEO of Match.com and tried to get him interested. I was pretty impressed. So you saw this already. This is President Kennedy's inaugural address, and the system will give you a very capsule summary of the individual's personality. It'll also give you a very detailed breakdown. We break the personality down into a vector, 52 numbers each between 0 and 1. And this is Kennedy. Less of an idealist than I would have thought, 62%, but I guess he's a politician, and no politician is going to survive very long if they're too idealistic. Another interesting service here is one called Concept Insights. And what this one will do is it'll take a document and it'll tell you the concepts that people are talking about. So if you like, it kind of pause through the verbiage and the words that are in there and say, oh, they're talking about education, or they're talking about books, or they're talking about money. And you can use this to actually, if you like, match something that you get over here with something you get over there by just looking at the underlying concepts between the two. I mentioned the natural language classifier. This one's a pretty simple question and answer application. You train it with a spreadsheet. Column 1 of the spreadsheet is a collection of questions. Column 2 for each row is the intent of that question. So you really train it to understand which questions match to this intent, which questions match to that intent. And then you can map those, if you like, to predefined categories of answers or kick-off business processes, whatever you like. As an example of the kind of application that's pretty easy to build, this was something we built for the Australian Open earlier this year. We trained the system to know about tennis players, about the Open, and the idea was to give an application to people who attended the Open, so they could learn about the players, they could learn about history of the event. And this is, as I said, there was some Ruby code in here. The code that you write to interact with these microservices is pretty simple stuff. Literally, you give it a question, and you get back a JSON structure with the set of possible answers to that question. Each answer has a set of evidence for why it believes that's the right answer, and confidence, which is a number between 0 and 1. And you can decide to show one answer, many answers, whatever you like. Very easy to use. So why are we doing this? One of the things that you see if you look at the kind of the market is a lot of companies like us, like others, are building platforms and are building applications in the space. IDC's view was by 2018, half of consumers will interact with systems like this, which brings us back to why I'm here today. We kind of knew up front that there was no way that IBM was going to corner the market on all applications of this type. So rather than try, what we decided to do was build a platform that enabled people to build their own applications as quickly as possible, hence decomposing Watson capabilities and adding new ones in as Bluemix microservices. So if you want to know a little more about this, www.ibm.com Watson. There's the developer cloud at the bottom, and yes, we are hiring. So I guess I have time for a couple of questions. Yeah.
So Watson apparently understands English, which is pretty cool. Does he understand any programming languages?
No, he can't code actually, and so I used to do that for a living. I've written compilers and the like in the previous lives. People ask me that all the time. They say, could you build an assistant for Watson that would? In order to do that, you're going to have to hook up, the equivalent of natural language processing to understand, pick your favorite language. So doable, but we haven't done it.
Okay. In theory, he could.
Yeah, well, or she, but yeah. Yes.
Last night I worked with some of the Watson API and all that. At that point, it's like 6 months ago, and there was no access to things like corpuses, personality insights, it's all live on a specific paper, so you can't actually change the relationship between certain personality traits and certain words. I guess, is there any intent to open things like corpus up so that you can actually have a corpus, I can put corpus in and have
It depends on the service. So some of the services can be trained, like the natural language classifier is easy to train, just give it a spreadsheet, and some of them not. You asked about personality insights, and there's actually an interesting story behind this. We found an academic in Texas who's been doing research on the use of language for 30 years. And what we did is we built the personality insights service using that, and I guess the invention that came from us was to show how we could calibrate the Personality Insights API with standard psychometric tests. I talked about the big 5 there, but I didn't mention it. So it's actually been calibrated to be 85% accurate with standard psychometric tests, which is why that service isn't trainable. What we're doing now, by the way, is teaching in other languages, which means you've got to understand idiomatically what kind of language that people use in Japanese or in French or in Italian or Spanish, whatever it might be.